Okay, so you guys, today we are going to put together, like I said yesterday, we're going to put together the two formulas that we did the previous 2 days. We're going to talk about the addition rule as well as the independence rule. You guys can see I put the answers up on the warm-up. I'm not going to talk through those, but if you want to jot down the answers and then work them out and make sure that you can do them, that would probably be a great idea. Okay, so we have two formulas at this point. Remember, we're only going to have three. So really, these are the two we're going to focus on through next Thursday. That's when your quiz is. And then we will add the third uh, week after that. So this says using either the addition rule or independence rule, set up an equation to answer each of the following. You guys, I've talked about this, but you're going to hear me stress it today. Addition rule means you see the word or. If you are given the A or B probability, you have to use the addition rule. Okay? I mean, you just need to connect that in your brain somehow, some way. You have to use the addition rule for or. So that is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay. Now, the next one is the independence rule. And you guys, I'm going to highlight the word independence because when we're doing these word problems today, if it says that two events are independent, kind of like what I just said about the or. As soon as you are given the or probability, you have to use the addition rule. If you are told that two things are independent, that is not by chance. That should lead you to the formula that you can use, okay? So we know from yesterday that our independence rule is the probability of A and B, so the probability of them happening together is the same thing as them happening separately. So the probability of A times the probability of B. So, I've talked about this briefly. Today it's going to be huge. These are long problems. You need to read through them, pull out the correct information, and write everything down. You guys, I know some of you, I say it, you ignore me. I promise your success is linked to being able to see all the information at once, which is very difficult to do if you don't pull it out and write it down. Okay? So that is my overall warning, public service announcement, yada, yada, yada. Okay? All right, so let's look at the first one. We have, the Town Cinema is next to Ryan's Bistro. A consultant surveyed 200 people who saw a particular movie at the Town Cinema and also ate at Ryan's Bistro. So that right there is setting up our sample space. He surveyed 200 people, so there's our sample space. Okay. The survey indicated that 80% liked the movie and 60% liked both the movie and their meal at Ryan's Bistro. Okay. Assume that liking the movie and liking a meal at Ryan's Bistro are independent events. All right, so we have independence there. So like I just said, when I say independence, that should cue you like, oh, I should probably use the independence rule at some point in this problem. That's what you should be thinking, okay? Sorry, guys. I'm going to try not to sniffle through this whole thing. Based on the survey, what is the probability that a randomly chosen moviegoer will like a meal at Ryan's Bistro? Okay, so let's pull out a couple different things. First, I always look at what am I being asked? Okay, so this says based on the survey, what's the probability that a randomly chosen moviegoer will like a meal at Ryan's Bistro? So the probability of Ryan's Bistro is what I am looking for. Okay, then I go through and I pull out anything else. It says that the survey indicated that 80% liked the movie. So the probability of a movie is 0.60, and 60% liked the movie and their meal. So the probability of the movie and the meal at Ryan's Bistro, I'm going to use RB so it's not M&M, is this should be a 0.80, sorry. And this is a 0.60, okay? So the survey indicated 80% liked the movie. Sorry, I just switched that. And 60% liked the movie and their meal at Ryan's Bistro. Okay. Now, if you notice, we do have a sample space. In this case, we don't need it because we were given probabilities that were already in percents. Before this, the problems we've done before, they just told us random numbers about how many people liked the movie and how many people liked the movie in their meal. So we had to figure out the percent for the probability. Here we don't have to do that. So I actually don't need this. Okay. All right. So independence. Think about this. The independence rule is the probability of Ryan's Bistro and their meal equals the probability of Ryan's Bistro times the probability of their meal. Okay, so what do we know? I am looking for the probability of Ryan's Bistro, so that's going to be my X. The probability of a meal is 0.80. And the probability of both, the and, it doesn't matter that I wrote them opposite ways, one and the other, is 0.60. So now you've set up an equation where you can solve for X. So you're going to divide both sides by 0.80. It's a simple one-step equation. Okay. And then all you need to do is solve, and you get X is 0.75. You guys, all of these we are going to report as percentages. So the probability that they liked a meal, no movie, but just the probability of liking a meal is 75%. Okay. All right. For number 2, we have Joel in a basketball game. Okay. He has just tied the game. He was fouled while shooting, so he is awarded a free throw. Moreover, the referee calls a technical foul on the other team because of bad behavior, so Joel's team is awarded a second free throw attempt. Okay. The coach assigns a different player, Rico, to shoot the second free throw. So we have Joel throwing one, Rico throwing the other. Joel has made 32 of 53 throws so far this season, while Rico has made 42 of 48. Assume that Joel and Rico making the free throws are independent events. What is the probability that Joel or Rico will make a free throw to win the game? All right, so you guys, keywords, independent or and is important as well. So what's the question asking? What is the probability that Joel or Rico will make the free throw? So I'm looking at the probability of Joel or Rico. That's the question I need to answer. Okay. Well, what else am I given? It says that Joel has made 32 of 53 throws. So the probability of Joel is 32 out of 50. And Rico has made 42 of 48. So the probability of Rico is 42 out of 48. Okay. So here, the other thing that's really important is that it says, assume that Joel and Rico making the free throws are independent events. You guys, that won't just be given to you for no reason at all. That is given to you specifically to use in the problem. So think about what you're looking for and what you're given. Here, you are asked for the or, which means you have to use addition rule. It's not an option to not use addition rule because it's the only way you're going to be able to solve for the or. So we have the probability of Joel or Rico equals the probability of Joel plus the probability of Rico minus the probability of Joel and Rico. Now, if you think about this, we don't have enough information to solve this because I'm looking for the or. I'm given the probability of Joel and the probability of Rico, but I'm not given the probability of Joel and Rico. However, this is why right here we are told they're independent events. You guys, look at your formulas. This right here is the same thing as this. So we're going to do some substitution. We're going to say that the probability of Joel or Rico is the probability of Joel plus the probability of Rico minus, I'm going to replace this. This is the and. Well, I know their independence. So according to my independence rule, this is equal to the probability of Joel times the probability of Rico. So I'm going to replace this with the probability of Joel times the probability of Rico. Okay. So this is the exact same thing as this. All I've done is switch them out because it's an equation. Okay. And the reason I could do that is because I was told that they were independent. All right. Well, now I can solve this question because I was given the single probabilities, the Joel and the Rico probabilities. And now that's all I need in order to solve. So this is what I'm looking for. I know the probability of Joel is 32 out of 50. I know the probability of Rico is 42 out of 48. And then I'm going to subtract 32 out of 50 times 42 out of 48. Okay, you guys, I'm going to do this in my calculator, which you won't be able to see. I'm going to just do it in my hand. But please take the second to pause the video and do this in your own calculator. I feel like some of you guys are going to start relying on me to do the math for you, and then you're going to get to the quiz and not be able to execute on your calculator. So please make sure that you can do that. When you put this in your calculator, if you do so correctly, and I did it all at once, I just used a lot of parentheses around every single fraction, you get 0.955, which means the probability that they're going to win the game is 95.5%. Okay. All right, let's go to the back. For a statistics project, Tina surveys a well-chosen sample that represents all of the students at her high school. She finds that 72% of the students at her school have played golf, and 27% of the students at her school have played golf and volleyball. Assume that playing golf and playing volleyball are independent events. Based on the survey, what is the probability that a randomly chosen student at Tina's school has played volleyball? All right. Question is asking the probability of volleyball. Okay, that's right here. What are we given? Well, we are told that 72% of the students have played golf. We are told that 27 have played golf and volleyball. And then even more importantly, we are told that they are independent events. You guys look at this. Write out everything you are given because it's going to be so much easier to see what formula you need to use. Like on the last problem, we were told they were independent events, but we weren't just using the independence rule. So please make sure that you're writing this stuff out. We have the probability of golf is 72%, so 0.72. The probability of golf and volleyball is 0.27. And that's all we're given. But then we're told they're independent events. Well, if they're independent, the probability of golf and volleyball should equal the probability of golf times probability of volleyball. Do we have everything we need to solve this question? Well, I'm looking for the probability of volleyball. Probability of golf is 0.72, and I'm told that the and is 0.27. So I do. I don't need to bring in the addition rule because I have everything I need. And there wasn't an or probability given, so it wouldn't have even been an option anyway. So just like this first problem, we're going to divide both sides by 0.72. Okay, when you take 0.27 and you divide it by 0.72, you get 0.375, which is your x. So there's a 37.5% chance that they play volleyball. Okay. All right, number 4. Emily and Nino are participating in an archery unit in their physical education class. Emily has hit inside the yellow region 16 times out of 40 shots. Nino has it inside the yellow region 15 times out of 30 shots. They are now partners in a Take Your Best Shot tournament. In the tournament, each partner shoots once and the best shot counts. Assuming that Emily's result and Nino's result are independent events, what is the probability that Emily or Nino will hit inside the yellow region based on their past performance? So you guys, this we're looking for the probability of Emily or Nino. So hopefully in your mind you're thinking, oh, that's addition rule, okay? So the probability of Emily or Nino is what I'm looking for, okay? So what do I know? Well, I know Emily is hit inside 16 out of 40 shots, so the probability of Emily is 16 out of 40. The probability of Nino is 15 out of 30. And we aren't given anything else other than the fact that they are independent. So I have to use the addition rule because I was told the or probability. However, I was also given the independence. So use that as a sign that there's going to be some sort of merging of our formulas like we did on the back of the, or the bottom of the front, okay? So the probability of Emily or Nino is the probability of Emily plus the probability of Nino minus the probability of Emily and Nino. But again, you guys, this we're going to switch out because we know they're independent and we don't have that probability. I have nothing to put in there, right? If I tried doing this right now, you guys, I would have X, don't write this down, equals 16 out of 40 plus 15 out of 30 minus another variable. Well, how do you solve that? You can't, which is why we merge our formulas. That's why you are told that they're independent, because now instead I can look at this and say, well, instead of using this, I'm going to say, well, that's the same thing as the probability of Emily times the probability of Nino because of my independence, right? The whole independence rule says that this is equal to that. So I'm going to replace that and now say that this is 16 out of 40 times 15 out of 30. Okay? So throw that in your calculator. Use a lot of parentheses. Sorry if you can hear my dog barking in the background. He wants to come in and say hi to everybody. 16 divided by 40, 15 divided by 30. So you end up with X equals 0.7. So that means there is a 70% chance that Emily or Nino will hit the inside the yellow region. Okay. All right. Last but not least, we have Louis Book Cafe. So at Louis Book Cafe, every sale is recorded as either reading or cafe. Last month, 67.5% of people who visited Louis spent money there, and 50% of the visitors made at least one cafe purchase. Assume that buying a reading item and buying a cafe item are independent events. What is the probability that the next visitor at Louis will buy a reading item based on last month's data? So what are we being asked? We want to know the probability of a reading item. Okay. We know that they're independent events. Okay, good to know. Let's look at our probabilities that we're given. It says that 67% of people who visited spent money there. Okay, well, it says every sale is recorded as either reading or cafe. So I'm not going to do the probability of money. That's not really going to get me anywhere based on the other information I'm given, because the other information I'm given says 50% of the visitors made at least one cafe purchase. So the probability of a cafe purchase is 0.50. So you guys, I want some combination of reading and cafe. I don't want to bring in a third event just called money. It wouldn't make sense. So this means the probability, every sale is recorded as either reading or cafe. So the probability of reading or cafe is 0.675 because it says last month 67.5% of people who visited spent money there. So the probability they spent money, which would be in either the reading section or the cafe section, is 67.5. Okay, so if we set up our formula, we have an or, so boom, addition rule, you have to use it. The probability of reading or cafe is the probability of reading plus the probability of cafe minus the probability of reading and cafe. Again, you guys, we aren't given enough information, so I'm going to replace this with the probability of reading times the probability of cafe, because They're independent. Okay, so that means I am looking at 0.675 equals x. I'm looking for the probability of reading, plus 0.50 minus x times 0.50. All right, so we have two x's. That's okay, because our unknown right now, this is what we're looking for, and it pops up twice. But it's the same unknown, so cool. Equation. We can solve this, right? We have 0.675 equals, because of what is about to happen, I'm going to put a 1 in front of my x. I never do that, but I'm going to right now. 1x plus 0.50 minus 0.50x. You guys, we have to combine like terms here. And the reason I put a 1 in front is because people have a hard time seeing that when your coefficients are variables. So if you notice over here, we have a 1x and a negative 0.5x. So when you combine those, it's as simple as adding your coefficients together. So 0.675 equals 1 minus 0.5 is 0.5x plus 0.50. Okay, now you can solve this. So we have 0.675 plus 0.5, so we end up with 1.175 when we add over our 0.5 over here. We're going to divide by 0.5. And I did something wrong. Hold on. Okay. What did I... Oh, you guys... Simple math, you know, always not my strong suit. 0.675 minus 0.5. Let's try that on. There's no 1 here. Oh my God. Sorry, guys. So strong. Had to screw up it at the end. This should just be 0.175. There we go. Hello. Duh. Sorry. 0.175 because I'm subtracting. This is why I should write out all of my steps, guys, right? I'm subtracting this. There we go. So now when I take that and divide by 0.5, I get x equals 0.35. So there is a 35% chance that the people who spent money did so in reading. Okay? All right, so highlight, underline, write everything down. I promise the only way to truly be successful 100% of the time, and you will actually do less work, is to front load the effort by writing everything down first. I know you guys don't like to do that because you think it's more work, but it's actually less work in this case. Okay, so work on your homework. Come see me Tuesday morning with any questions you have. And then obviously we will have Tuesday and Wednesday to work on the review. And don't forget about that flex learning assignment. If you did not get it yesterday or you lost yours, please ask the sub for another one. Okay? Have a good weekend.